Okay, welcome back to the channel. We're going to be going through paper 2 now of the November 2022 past papers. These, you can find them on like Maths Genie or online. They should be quite easily accessible. So good ones to have a go at if you're prepping for your mocks or the real thing. So yeah, might as well get straight into it. Remember guys, this is a calculator paper, so use your calculator. I wouldn't even waste any brain cells doing it yourself. That's what I say to my students all the time. Don't waste brain cells, just put it in the calculator. Alright, let's start at the beginning. Write them in order of size. Start with the smallest. So in that case, it's going to be the most negative number first, which is -7. Sometimes I like to cross them off when I've written them, so I know that they're gone. I don't need to think about them. Next one's going to be -2. Okay, then -1, because these are all negative numbers. Then 0, and then 7. Alright, and I've gone through all of them. Lovely stuff. Writing this as a fraction. Right, remember 37% as a decimal, for example, 0.37. If you can't think directly from percentage to fraction, it's nice middle ground. Pop a decimal in there. And then as a fraction, 0.37 as a fraction is 37 out of 100. Okay, so that's all you need to put for that. Don't waste time trying to simplify. This doesn't anyway, but don't bother. Honestly, don't bother. Unless it tells you simplify, don't bother. This is a weird one. 7th odd number. That's so niche. Okay, so your first number is 1. Then it goes 3, 5, 7, 9, 11, 13, 15, 17. Right, I must have done the 7 by now. 1, 2, 3, 4, 5, 6, 7. 13. Right. Centimeters to millimeters, some conversions now. Now, all you need to know are your conversions. So, for example, I would probably get your ruler out that you should have anyway. Alright, get that out because that'll help you. Alright. Well, I've just popped one on the screen to help us. So if I was in the exam, I have my ruler. Alright, millimeters are the tiny little lines. Alright, and centimeters are these ones. Alright, so in 1 centimeter, there are 10 of these little lines. 10 millimeters. Okay, so we've got 53 centimeters. Okay, so from here to here, we're timesing it by 10. So we need to times that by 10 as well. So it's 530 millimeters. Okay, definitely, if you're converting centimeters to millimeters, get your ruler out. Alright, it's the easiest way to help you out. Next, 4 cards. There's a number on each card. Write down the smallest 4-digit even number that can be made. Okay, so it's an even number and it's got to be 4 digits and we're looking for a small. Okay, best way to look at this one, alright, is it's got to be really small. So we're going to have, it's 1,000 or something, or 3,000 or something, 6,000 or something, 7,000 or something, 4,000 or something. The smallest number we can make is definitely having that 3 as our first digit. Okay, because it's 3,000 and then blah, 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 blah. Okay, we want it to be really, really small. Okay, so our next column is really important. Right, we're either going 3,400 something, 3,700 something, 3,600 something. Okay, we aren't going to choose 7 or 6, we're definitely going to choose 4, because that makes it quite small. Right, now, we have to be careful. It's asking for an even number. Even numbers either end in a 0, a 2, a 4, a 6, or an 8. So we're kind of being forced to put the 6 at the end. Even though, in theory, the number would be smaller if you went the other way around, but it wouldn't be even anymore. Okay, so we're going to put the 6 at the end. So that little gap is for the 7. Alright, 3, 4, 7, 6. That's the only answer you can get for this one. Alright. Okay, we've got quadrilateral. Oh, I've got to get a ruler out now. This is going to be a bit tricky because I've got an E version of it. So I'm just going to pause a second. Alright, so I've got my calculator. I've got my ruler out, sorry, to the length that it is actually in the paper. and we've actually been asked to measure side AB. So what I'm going to do is I'm just going to, I'll show you which AB is. The hardest bit is just make sure you get the right line. AB is this line here. So that's the one that we're measuring. So I'm just going to grab my ruler. Just grab my ruler. Just need to line it up. Bit trickier because I'm doing on here, but if you just had a physical copy, it would probably be easier than what I'm having to do. But I think, even though I've not lined up perfectly, oh, that's better. 4.5 centimeters, I would say that is 4.5. Okay, goes from there to there. Yeah. Oh, measures the angle. Right, protractor's coming out. Fortunately about protractors is it doesn't matter about the distance for that one, so I'm just going to delete my ruler. I don't need it anymore. Just going to get my protractor out. And we're doing the angle marked X. Alright, so this is going to get a bit bigger just to make it easier for us. We just need to line up the line. This is really important. This is lined up nicely. Just like so. And then you can just read the number off. I think, if you look at it, the angle, right, that is bigger than 90 degrees. Alright, so when you're looking at your number, whether you're using the outside number or the inside number, it's going to be the outside number in this case, alright, because it's bigger than 90 degrees. So that is going to be 110 degrees. Alright. Right, on to the next one, question 7. Miles writes down the distance readings from his car at the start and the end of a journey. Right, so at the start of the journey, so basically what that's saying is his car will say how many miles he's driven. Right, so at the start of his journey, the total amount of miles that have been driven in that car is 12,468, and at the end of the journey, it's 12,845. Alright, so you can work out how many miles he's done in that journey. It's quite a journey he's done there. Alright, and he also knows the cost per mile. Okay, so we're going to find out firstly how many miles this journey was, and then we'll use that to find out the total cost. Alright, so let's have a look. We can use our calculator for this, but the first calculation we'll be doing is 12,845 subtract 12,468. We'll just pop that into my calculator. You might beat me to it. 845 subtract 12,468. So 377. Okay, so his journey was 377 miles. Right, and it's 13p per mile. Now, because the question says give your answer in pounds, there's a pound sign down there, I'm going to convert that 13p into pounds. Right, 13p is 0.13 pounds. Right, you divide it by 100. So my next final calculation will be 377 times 0.13. We'll pop that into our calculators, and whatever we get, that will be the answer. So we get 49.01. Right, and that's the cost of this journey. So 49.01. All right. Next question. Safia wants to hire a van. She uses this rule to work out the cost of hiring a van for a number of days. So we've got some like little formula thing we're going to be using. Right, so we're going to use this formula. So Safia's hired it for 7 days, so we've just got to work out the cost. Actually, not too bad a question, because we've got a formula. So we just need to put in our calculator 45 times the number of days, which is 7. Again, it's calculate paper, so don't waste your brain cells. Just write down your steps, and you'll get £315. Alright, on to the next one. Question 9, we're about to test our art skills by doing some drawing of a bar chart. Shows information about students who are late to school each day 1 week. Alright, so the easiest way, you're going to be wanting on your y-axis to be about the numbers. Okay, so we're going to need to get some sort of scale going. And then on the x-axis, we're going to be looking at the days of the week. Alright, so if we start with our scale, if we're looking at what's the highest number, we need to just look at the biggest number. So we've got Tuesday's 10, so it needs to at least reach 10. So I reckon we can go up in ones, but let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Lovely. Alright, so we're just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you can just might as well pop the 11 up. Alright, and then we want to kind of separate out the bars with an equal gap between them. So just because it just makes it clearer to look at and interpret. So Monday's going to be the second one in. I'm just going to put Mon, easier. And then Tuesday, and then Wednesday, and then Thursday, and then Friday. Alright, and that's how we're just going to lay it out like that. Alright, now we've just got to draw our bars. So we just got to make sure we get the right number. So Monday was 9, so my bar is going up to 9. Alright, so you want to make sure you draw it nicely. Probably a bit neater than I have, to be honest. So that's for 9. Okay, and then Tuesday was 10. So we're going to do the same thing. All the way up to 10. They should be about the same width as well. Wednesday was 8. Oops. Alright. Thursday was 6. And Friday was 3. Alright. Alright, and that is pretty much done, although I haven't put any labels on it. So even though I've labelled the numbers and I've labelled Monday, Tuesday, Wednesday, Thursday, Friday, you do need to put on that the y-axis, how high up it's going, whatever your title was here. So in this case it was number of students, so I'm going to just pop that on there, just to make it really, really clear to the examiner what that means. So there's no excuse to not give us full marks for a beautiful bar chart, yeah? Alright. Okay, we've got a bus timetable. This is actually quite useful, because you all read bus timetables. Normally they're on apps now, but it's still useful to get an idea of how frequently they're running. Okay, so we've got some Wigan and Bolton. So it starts at Wigan, and then these are its stops along the way until it gets to Bolton at the bottom. So how many minutes should the 7:20 bus, okay, so 7:20 bus, it's this one here, take to go from Wigan to Lowestoft? So we're going from Wigan to Lowestoft. Okay, so we're starting at 7:20 and we're getting in at 8:09. Now to get to 8 o'clock, that is plus 40 mins. Alright, that takes you to 8 o'clock, and then 9 more. So in total, that's 49 minutes. Alright. Easiest way to do it, I would say. Alison goes from Blackrod to Bolton by bus. Okay, so starting at Blackrod, that's their stop. So let's change highlighters now. We're going from Blackrod all the way to Bolton for a job. Alison leaves her house at 8 o'clock. Okay, so we need to look at which bus you could actually realistically get. She takes 7 minutes to walk to the bus stop in Blackrod, so she'd get to the bus stop at 8:07. Alright, and she takes 15 minutes to walk from the bus stop in Bolton to work, and she needs to be at work for 9:20. Alright, so the bus that we can get, if we're at Blackrod, we can't get the 7:49, she's missed it, too late. We could get the 8:24, but there's one we can get this earlier, and that's the 8:09. That is our bus. Alison, hop on. She's hopping on the 8:09 bus, alright? And she's got to get to Bolton from there, alright? So she gets off the bus at 8:58 then, okay? Gets 8:58. So let's first put some of the stuff down so we can get the marks, because it does say you must show how to get to your answer, alright? So Alison gets to the bus stop at 8:07. She gets the 8:09 bus. Okay. Arrives in Bolton at 8:58. Okay. And it's a 15-minute walk. So we need to do... So to get to 9 o'clock, that is plus 2 minutes. And then we need to add on 13 more minutes. Because we're adding on 15 minutes for the walking. That's what we're doing at the moment. Okay, so it's 9:13. So she arrives at work at 9:13. Arrives at work at 9:13. So yes, she will be on time. Alright, that's all it is. Looks a bit scarier than it needs to be honest with you. It's actually not too bad. You don't even really need your calculator for that one. You're more welcome to use one, but you don't really need it. Right, next. Alright, we've got some words. Wordy one. 214 people going on some school trip. Lucky day, lucky them. People are either adults or children. Right, so we've been told there are 14 adults on the trip. So first things first, 14 adults on the trip, 214 altogether. So first thing we can say, 214 minus 14 is 200. So there are 200 children. 35% of the children on the trip are wearing a hat. Find the number who are not wearing a hat. Really random stuff we've been asked to find in this question. Fair enough. Okay, to do this, you want to get your calculator out. First step first, we're going to find 35%. To find 35% when you've got a calculator, it's actually quite straightforward. You times it by the decimal. So the decimal equivalent. Alright, so if 35% is a decimal is 0.35. There is a slightly quicker way of doing this. You might have done it that way, but this way this is fine. Alright, so there are 70 children. Okay, so that is wearing a hat. Wearing a hat. Okay, so we just need to do 200, subtract the 70, and you get 130 children. Okay, that is your answer. Alright, nice and straightforward. Right, next. And that is for four marks. That's nice. I'm telling you, that's nice. You've got a calculator as well. Just all bit you might get stuck is probably knowing that you can times it by 0.35. Alright, or you can, if you know how to do it in your calculator, put times by 35%. That's fine too. 5/8 of 132. Again, don't use your brain too much for this one. Anywhere you see of in a paper, that just means multiply. So that means 5/8 times 132. That's all you need to do. So find your fraction key on your calculator. You want to pause, take a second. I'm going to do the same. Alright, make sure your 5 goes in the top, 8 goes in the bottom, and you go, it just needs to look identical to what is written here. If it looks the same, you're fine. Alright, so you should get 82.5. Right, don't do it yourself, just use your calculator. If you really wanted to, you could divide it by 8 and then times it by 5. You'll get the same answer, so honestly, I wouldn't even bother. But if you want to do it like that, you're more than welcome to. Fractions in order of size, I've got to be honest with you, that's not very easy to tell by just looking. Fractions to compare sizes of are a pain unless the the denominators are the same. So you could make the denominators the same if you wanted to. Or use the fact you have a calculator and turn them all into decimals. That's probably what I would do. Okay, but make sure you write a few decimal places. So I'm going to put 3/8 in my calculator. Alright, 3/8, which is 0.375 as a decimal. Okay, and then I'm going to do 9/32s. 9 divided. If you're not sure how to do the fraction key, you can just put a division in, that's fine. The second one, we've got 0.281. I'm not going to write any more digits than that for now, but we might need to come back to that. 1/4 I know anyway, because that's 0.25, but you might not, and you can pop it in otherwise. And the last one, 21 divided by 64, is 0.328. Right, now we've done that, we can order these. So we're starting with the smallest, right, the smallest fraction. So we need to look at our decimals and go through a column at a time. So they've all got a 0 in the ones column. Right, so they're all zeros, so that's no good. So we're going to look at our tenths column next. We've got a 3 in this one, a 2, a 2, and a 3. So we're going smallest, it's going to be one of the 2s. Right, so it's either this one or this one. So we're going to look to the next column. This has a 5 in it, this has an 8 in it. 5 is smaller than 8, so our first one, this is our smallest. So this is going to be our first one. In fact, let's write that in black. This is going to go first. But it's asked to write the fraction, so I'm going to write 1/4. Okay. Now, we can do the second one quite quickly because it's the only other one with a 2 in the tenths column. So that's the next one, so 9/32. Alright. Next, we're looking at comparing these two now. Again, they both have 3s, but if we look at the next column, that has a 2, that has a 7. 2 is quite a bit smaller than 7, so this bad boy must be next. And so that's last. It's the biggest. 3/8 is the biggest. Alright? That's it. You just pop it in your calculator and you're good to go. Don't overcomplicate that at all. Alright? Alright, we've got a comparison, we've got some offers. So we're looking at some things about milk, apparently. Alright, so we've got which one is better value for money, classic. Got milk at 2 pints for 75p, but you pay 2 bottles and you get 1 free. Okay, and then we've got pay for 1 bottle and get another bottle half price. Okay, so we pay for 2 bottles of that milk, okay, and get 1 free. So 2 bottles would be, so 75 times 2, which is £1.50, and then we get 1 for free. So we get, with that deal, we pay £1.50, and we get, how many pints of milk do we get? So we get 6 pints, am I right in saying 6 pints? So we double it, so that'll be 4 pints, and we get an extra one for free, so we get 6 pints. Okay, so we'll call this one shop, we'll go A and B. So for A, it costs £1.50, and that for 6 pints with that deal. Alright, now we'll look at B. So B, we pay for 1 bottle, and then we get another bottle half price. So half price, so £1.28 divided by 2 is 0.64. Okay, so we're going to get for bottle B, we're going to get £1.28 plus 0.64 is £1.92, but that is for 8 pints. Okay, that's for 8 pints. So now you've got 2 choices, alright, 2 choices here. We can compare the prices directly, or we can compare the pints directly. I personally find it easier to compare the pints, so I think that's that's basically what we're doing, right? We're going to find out how much 1 pint is for both of these. 1 pint. Because then we can compare that one directly and see which is cheaper. Alright, so for this top one, we're going to be dividing it by 6. Alright, divide it by 6, so that's £1.50 divided by 6, which is 25p. Okay, 0.25 pounds. Okay, for 1 pint. And then we're doing £1.92 divided by 8. So we're dividing by 8. And we also so close, 0.24. Okay, so B is cheaper, alright, value for money by 1 pence. Okay, so I'm just going to say offer B is cheaper by 1p. Alright. Or for the 4 pints is better, yeah? But yeah, if you label them A and B, they can use that to see what you're saying. Makes it a bit easier. Okay, we're coming into some algebra now. Algebra, I love a bit of algebra, me. Okay, all we're going to do is collect. This is just put all the C's together, put all the D's together. Right, these are the C's, these are your D's. I'm going to put a little 1 there as well, just to help us out. So you could do 4C plus 3C, that is 7C. Alright, and then we're doing 7D minus 1D, which is 6. Oh gosh, too many equal signs. 6D. Alright, literally all you're doing is you're putting all the C's together and then you're putting all the D's together. So you get 7C plus 6D. Alright, it's a plus because it's a positive 6D. Alright. Solving this is not easy by any means. You've got 2 ways of going about it. I will show you both. Alright. Usually I would always expand it first because I just think it's easier to picture, but you could also, if you wanted to get rid of that, you could get rid of that 5 straight away by dividing it by 5. That is one way you could do it. But I won't actually go through that method, but then you just solve it like a normal equation. I'll expand it. Go on, I'm expanding it, I want to. Right, we're going to times these together, so we get 10m. And then I'm going to times these together, so you get minus 30. Alright, 5 times 6 is 30. Equals 40. Alright. Remember, it was solved. Apologies. Sorry, I cut out. Our end goal is to get m equals. That's the aim of the game. Alright, we're solving. Look, m equals. That's what we want. Alright, so we need to get to that stage. So, we need to get rid of anything. This 10's got to go and this 30's got to go. Alright, but the 30's going first. Alright, because it's not attached to the m. We do anything attached to the m at the end. Alright, that's the last step to get rid of it. For now, let's get rid of this minus 30. To get rid of a minus, we do the opposite, we plus. Right, so we can say it's gone. So 10m's is equal to 70. Remember, 10m means 10 times m. You might already have worked out what m is. But to get rid of that, we're going to divide by 10. See you later. So m is equal to 7. Alright, 7. Alright. Okay. We've got a write an expression, so it's going to be something like 4y plus 3x, or something like that. Alright. We've got, oh, yeah, easy, we can do this. There are x sweets in a box. Alright. We've been told we've got 3 boxes. And we've got y sweets in a packet. And we've been told we want 2 packets. So, if there's x in each box and we have 3 boxes, we can just say the total amount in all the boxes is 3x. Okay, that's for the boxes. But we also have 2 packets. So we're adding on those 2 packets, which we can say as y in each packet, so that's 2y. That is it. Nothing more. That's all there is to it. Alright, that's actually not too bad once you go through the question. Oh, we've got ourselves a stem and leaf. We're one with nature. The trees have come out. Okay, we're doing a stem and a leaf diagram. These are so easy once you have seen a couple. Alright, we just need to work out the stem, these numbers. Alright, that's the tens column in this case because all our numbers are tens. We've only got 70s, 80s and 90s. Oh no, we've got 100 as well. My bad. Okay, so we're going to go for the first one is going to be a 7. Okay, that means 70. Okay, and then it's going to be 8 for 80. Right, then it's going to be 9 for 90. Yeah, and this one's a bit weird. Doesn't normally cross over into the hundreds. And then we're going to go 10 for 100s. Right, 100 and something. That's our first step. Our next step is just to go through the numbers, okay, from smallest to largest. So the smallest number on there is 71, right? So the first number I'm going to put here is a 1, because 7 line 1 means 71. So you can even put your key in straight away. 7 line 1 equals 71 stickers. Is it stickers? Yeah, stickers. Alright, I know it looks a bit weird, because if you want to do your ones like that to make it a bit more obvious, you can. Alright, that's the first number. Right, we can cross it off because we've done it. Alright, that's the first number. There's another 71 though, so I'm going to do another one and then cross it off. Now we're just looking at any more 70s. I see a 74, so we'll do 74 next and then cross it off. And I see a 75, so I'm going to put a 5 there and cross it off. And there's a 7, put a 7 there and cross it off. That's all the 70s, I believe. Yep, we're on to the 80s now. So the smallest one is 82, write a 2 and cross it off. Then it's 84, put a 4, cross it off. And then, where are we at now? 85, put a 5, cross it off. 86, put a 6, cross it off. You get the idea. 7, 8, and 9. Alright, nearly there. Now on the 90s, 91, 94, 97, 98. Crikey. And last but not least, 103. Now we've done all of them. Thank goodness. 3 marks in the bag for that. Quite a lot of work actually, if you think about it. It's not like super hard, it's just a lot of effort. Alright, now we're finding the median. Median, we need to know what that means. Median is middle. Alright, so we've got to go through the stem and leaf and keep crossing off until we get to the middle one. So we cross one off the top and then the bottom at the same time. Alright, so for example, I'm just going to do little, I don't want to cross them because I think it will ruin the stem and leaf, so I'm just going to do little lines underneath. Okay, so that's one from each end. Another one from each end. You just keep going, but do go quite slowly. Okay, so now we've reached, it's going to be 80 something is our answer, right? Oh, I can see it. There it is, 86 is our answer. Lovely. Alright, and if you can master stem and leaf, that's 5 marks in the bag there. Alright, you get a load of marks for just doing the actual stem and leaf and then finding that middle number. Get another one. And if you really don't want to do it in a stem and leaf, you can write them all out and then find the middle doing that, but that is a bit of a faff. I wouldn't recommend. But if you want to, I'm not going to stop you. Water flows through each of the pipes that fill a lake at the same rate. It takes 4 of the pipes 12 hours to fill the lake. Work out how many hours it would take 6 pipes to fill 1/4 of the lake. Alright, so if it takes 4 pipes 12 hours, 1 pipe's going to take 4 times as long, right? Because the more pipes you have, the quicker it will be to fill this lake. So if it takes 4 pipes 12 hours, 4 pipes 12 hours, to get 1 pipe, we need to do 4 times 12. Because it's going to take a long time for 1 pipe to fill. If you imagine you have this massive lake and only 1 pipe going to it, that's going to take ages. Or if you're filling a paddling pool with 1 hose, that's going to take longer than getting like 4 or 5 hoses in there. Yeah, so it's going to take longer, so we need times. So it's going to take 1 pipe 48 hours. So that's for 1 pipe. 1 pipe. Right? We have 6 pipes, so it's going to take 1/6 of the time. Alright, so 48 divided by 6 is 8. Okay, so it's going to take 8 hours. My goodness, 8 hours for 6 pipes. Okay, but we only want to fill 1/4 of it apparently. Don't know why. So we need to divide that by 4. So it's just going to take 2 hours. That's all. Just a cheeky 2 hours to fill 1/4 of the lake for 6 pipes. Alright. And that's the end of that page, isn't it? Yeah, moving on. 17, okay, we've got one of these annoying tables. We need to add an extra column to this. Alright, first things first, we're finding the mean, okay, an estimate for the mean, so it's not going to be exact. And because it's a grouped frequency table, we call these, because they're in groups, you're like, well, what number do I use? Do I use 150, 160? We find the middle of each of these. So I'm just going to add a little section. I'm just going to pop them just in between the two bits. We don't need to add a whole column for that. But this is going to be 155. We're going to use 165, 175, 185, and 195 instead. Okay, because what we're going to do is we're going to multiply all of those by these numbers here. And we're going to use those numbers in a moment. Alright, so we're going to add our extra column. Doesn't need to be anything too fancy. Alright, I'm just going to get my calculator and start working these out. Okay, so we've got 1. I suggest you do the same. Try and beat me if you can. Or just sit there and watch if you want, can't be bothered. 175 times 24. 185 times, oh gosh, times 30. I'll explain in a moment why we're doing this as well. Okay, now when you're normally finding the mean, you add up all the numbers and divide by how many numbers you have, alright? But we have there's a lot of kids here. There are 80 teenagers here, right? All of them having different heights. Right, and they're in groups, and we're working out the mean height. All right, so we need to calculate all of the. We need to have. There are 8 of them that have roughly 155, so we need to times that by 8 because that gives us all of that height. But then we've got all these other heights to add on as well. So we need to add up all of this column here. All right, and that's going to be the top of our fraction. You know when you add them all up on the calculator, then divide by how many, and we're going to divide that by this total here, which is 80, which we worked out earlier. This is just all of the frequencies added up. So if we add up all of those ones, so 12440 plus 2310 plus 4200 plus 5550 plus 780, we get 14080, and we're going to divide that by 80 to give us 176 centimetres. And it is an estimate. It's not exact because we're guessing all of these. We're saying, well, it's probably, let's just say everyone's in the middle, you know, that might account for some bit bigger, bit smaller. So it's just an estimate. We don't know if that's the exact answer, which is why if you ever get asked for an estimate of the mean, it's probably going to be in a case like this where you've got a table, because otherwise they're pretty exact. All right, number 18, getting there. Scatter graph, alright, shows the amount of rainfall, classic, in millimetres, and the number of hours of sunshine for each of 10 English towns on the same day. Alright, so set the scene. Alright, it's a rainy day for some. Actually, is it a rainy day? Yeah, it's quite a rainy day. And the hours of sunshine. And it's saying that something's an outlier. Okay, an outlier just means one that doesn't look quite right with the rest of them. If I were to draw a line through this, if I was to guess a line through this, it looks like it's roughly going like that. Roughly, right? One of those numbers doesn't work with me. One of them doesn't work. And that is this one here. It's so out of place. It's nowhere near the rest of them. So that's my outlier, right? And it's asked for the coordinates. So it's 2 in the x direction. Remember, this is the x. We do that first. And going across, that's 1. 2, 1. Okay, it just looks off. Alright, is that all that has to do? We pop back. It looks like as the rain increases, so as more rain is falling, you get less sunshine. Okay, that's what it's saying to me. Alright, the more rain there is, the 7 hours of sunshine. 7 hours of sunshine. So that is somewhere along here. Okay, and what I've already done ahead of the game is I've drawn myself a line of best fit. That's what you will need to do. Now I might adjust it slightly so it looks a little bit better. But essentially, your aim, you need to draw yourself a line so that you've got x's on roughly the same amount of x's on both sides. Not a super easy one on this case, I wouldn't say. In fact, I think that's not a very good line for myself. Everyone will have, well, probably have slightly different answers to this one. Okay, and then we follow along 7 and see where that takes us. What are we saying? I'm going to say 3.5. Alright, so adjusting my scatter graph, I'm going to say it's about 3.4, so that's what I'm going to pop as my answer. Oh, right, I was going to say that would make no sense if that was all it was. Okay, ignoring the outlier, describe the relationship between the amount of rainfall and the number of hours of sunshine there is. So that's all I'm going to say. Just literally say that. The more rainfall there is, the less sunshine there is. That's all it is. Alright? Just say what you see. Okay, on the same day in another English town there were 7 hours of sunshine. Using the scatter graph, estimate the amount of rainfall in this town on this day. So we're looking at 7. I'm going to say it's about 3.4 millimetres from going back and looking at that line of best fit that we've drawn. Right, there will be some slight variation between people on that. Alright, next. Okay, the front elevation of the plan of a solid, okay, shown on the grid. On the grid, draw the side elevation of the solid from the direction of the arrow. So we've been given the front, we've got to draw the side of it. Okay. Not an easy one, I wouldn't say. For me personally, I've always found these sorts of things a bit trickier. But we're going to do it. We got this. First things first, we're looking at it from the side, from the arrow. So we're looking from this side. So if you imagine, we need to work out how tall it's going to look from the side firstly. Okay, so if we count up the side, 1, 2, 3, 4, 5, it's definitely going to be 5 tall from looking at it from the side view. So 1, 2, 3, 4, 5. Okay, that's our side view. Right, and it says on the top how far along this goes. Okay, so it goes this far, you know, that's if you imagine you're looking at it from above, really, on the plan. So it goes back 3 places. So that's going to mean when we're looking from the side, it's going to go 3 across to the side, like that. Okay, so essentially it's going to be a rectangle, right? A rectangle like that. Okay, but you do want to break it up based on using the plan and the front elevation to help us. After that this first bit, that's when it really shoots up. So after that, we want to put a little line across like this. Okay, that's that first bit. And then we've got that actual front. It takes another jump after that, 2 bars later. So this is the first bit, and then there's a second bit there, another little spike. So we're going to pop that on there as well. And that's done, right? Again, like I said, they are not my favourite thing in the world. I would rather not have to do them, but there we are. Got to be done. There's always got to be something in maths, so you're just like, oh no, please no. Send prayers. Moving on. Sequences, thank you. Some sanity. Nth term. Expression in terms of n, blah, blah, blah. Find the nth term. That's what you need, nth term. Okay, if you are not sure what nth term means and got a clue, look at part B. Nth term of a different sequence is this. So they're looking like something like that. I'm expecting something n plus something or take away something or whatever. Okay, first step to find the nth term is how much does it go up by? That goes up 6 plus 6 plus 6 plus 6. Okay, so the first step, I can tell you straight away it's going to be 6n plus something or minus something. Okay, half the job's done already. 6n plus or minus something, we don't know what. So now we imagine n is 1. So if n is 1, the 6n times table goes 6, 12, 18, 24. But our sequence is 7, 13, 19, 25. So what do I need to add to get from 6 to 7? That's all I need to think. Well, that's just 1. Okay, so all my nth term is 6n plus 1. And that's done. Alright? 6n plus 1. Because the 6n that just means the 6 times table, because 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 13, etc. Okay, so 6m plus 1. Then it says, this is the part B, bit spicing things up, is negative 58 a term in this sequence? To be a term in this sequence, n's going to have to be like a whole number, like 4 or 5 or 6 or 7. Basically, it can't be like 0.2 or 54.3. You know, it's got to be a whole number. So we're going to just write an equation. Let's make them equal and see what we get for n. See what number we get. Alright, that's all we've got to do. So, at the moment, we've got some stuff on the n side. It's going to be our n side. So I'm going to leave negative 6n. That can stay. We need to move that 8. So plus 8. To move a plus, we subtract. Don't be deceived. That minus is really attached to the 6. It's not really attached to that 8. It would be before it if it was the case. So we're going to subtract 8. So we get, be careful as well, we're doing negative 58, take away 8. If you feel like you need to get your calculator out to make sure you don't make a mistake, do it. Alright, it should be negative 66. Right. Now we're going to divide that, because remember these guys are times in, divide that number by negative 6. Okay, divide it by negative 6. So we get 11. Alright, so if you're using your calculator really carefully, you will say that n is 11. So you can say yes, 58, negative 58 is the 11th term. Yeah? Job done. Bosh. Okay? Getting there. How many more? We can't have too many more. We've been mathsing it for hours now. Okay. We've got Jason's garden. What a lovely garden he has. We've got some rectangles, we've got a triangle in there, and we've got part of a circle. Looks like, to me, that is a quarter of a circle, actually. Alright. He's going to cover his garden with grass seed. Okay, for now, we're going to ignore the waffle that is down there. We're going to ignore that for a minute. Okay. All we need from that is the fact that he's covering his garden, which means we need to find out the area of his garden. That's all we need to find. He's covering the whole thing, by the looks of things, with grass seed. So we need to find the area of the whole garden. This is not easy by any means. Right, there's a lot going on here. Let's start with the rectangles. They're easiest. So, this rectangle here, remember area of rectangle, you just times how wide it is by how tall it is. So 11 times 7. That is 77 meters squared. Easy start. Okay, and then we've got this rectangle here. That is 9 times 7, which is 63 meters squared. 2 done already. Alright, we've got triangle next. Now the triangle is 9 one way and 11 the other way. Okay, so 9 and 11. So we're going to do 9 times 11, which is 99. But it's a triangle. So if it was a rectangle, if it was like this, that would be the answer, 99. But it's a triangle, so we half it. Okay, so we need to do 99 divided by 2. Just going to go back a sec, just get rid of those lines. And we get 49.5. Again, you can just use your calculator. Meters squared. Now we've got an area of a circle to do. So you're going to need to look at your formula book for this one. Alright? Area of a circle, and I'm just going to draw a circle on the side just to help us out in a moment. Oops, not that small. Apologies. Area of a circle, right? The formula, so this is the radius. In fact, let's draw the radius here. R is pi times the radius squared. That's the formula for the area of the whole circle. Okay, so if we imagine this is part of a circle, it would keep going like this. So this little length here goes from the middle, says centre, to the edge, from the centre to the edge. So we know the radius of this circle is 7. You can look at it here or here. 7, 7. So to find the area of an entire circle, so if we had the whole thing, we'd do pi times 7 squared. So if you do that, pi, find yourself where pi is. and you can either leave it exact or write it as a decimal. So if you left it exact, you get 49 pi. Otherwise, you get 153.9. Yeah, 9, that's fine. Alright, but that's massive. Alright, that wouldn't even make sense for this little section here, would it? That's way too big. But it's a quarter of the circle. So if we've got the whole circle, we want a quarter, we need to divide that number by 4. Divided by 4, again, just use your calculator. You get 38.5 meters squared. Again, I'm just going to do to one decimal place. Alright, that is your whole area. We need to add it all up now. We're going to add it all up. So 38.5 plus 77 plus 63 plus 49.5 equals, so I'm just going to add them all up now on my calculator. But again, you'd write the steps down. 227.98. Now I've been doing to one decimal place the whole time, so I really probably should be quite consistent to that, but we'll go for 2 decimal places, because if 1 decimal place, we'll bump it up to 228. Right, so we'll leave it for now. 2 decimal places now. Okay, that is our total area. That's our area of the garden. Alright, that's his garden area. Now we'll look at whatever the blab is about, you know, words. Each bag of grass seed will cover 14 meters squared, and it costs £10.95. Okay, so we need to work out how many bags he's going to need. So that's the total area. We can divide that by 14. So 227.98 divided by 14. 16.28 bags. Now, I don't know about you, but you can't go to the shop and buy 0.28 of a bag, right? So you can't buy 16 bags. You're going to need 17 bags. Okay, so we're going to do 17 and times by the cost to tell us how much it costs him to sort out his garden. Right, it's going to cost that bloke £186.15 to sort out his garden. Fair play. Alright, that was a big boy, to be fair. It's a 5 marker, so it's not going to be easy. But even if you look at that and think, I ain't got a blooming clue, you could get marks for finding the area of that rectangle, or both rectangles, and you can find the area of a triangle. And to be honest, I'm sure if you thought about it deeply, you could find the area of a circle as well. It's just finding these things and putting it all together is the hardest bit, is combining it all. Alright, but use what you've been given and you'll be alright. Okay, I'm gonna move on to the next one. We're nearly there. Okay, this we're getting a bit of trigonometry's popped out. And why do I know it's trigonometry? Because I see a triangle, I see angles, and I see lengths. That shouts to me, trig. If you've got lengths and an angle, and a triangle, it's trig. Alright? So, we need to work out which one. So, I'm going to label the triangle. So, we've got the hypotenuse first, which is always opposite that right angle. That's H. That's your hypotenuse. And then we've got opposite the angle. We'll give this one O. And then the last one is A, which is next to the angle. Adjacent means next to. But I always do A last, because O and H just seem easier to me. Now we need to decide about which one of those 3 letters we don't care about. And I'm telling you, O, I couldn't care less. We don't need you. I'm sorry, we don't. There's no number here. There's no letter there. There's no X or anything. Don't care. So now we need to know which one are we going to use, sine, cos, or tan. Okay, if you remember, sine X equals O over H, cos X equals A over H. I should do a capital really. And tan X equals O over A. So which one of those has A and H? Have a little look. This one. Okay, cos. So my calculation, cos X, do you know what, I shouldn't have used X, because that's confusing. I'm just going to rub out the X's a minute, and I'll explain why I've done that. Okay, instead of writing X, it would be better to do the little angle sign. This is called theta, but it just means a little angle sign. The reason why I've taken out the X is because they've used X in the question. If they used a different letter, I could have got away with it, but it's just going to be confusing to use x in the angle bit, so I've got rid of it. Alright, so cos theta, so cos of the angle in this question is 53. It's equal to a on the top, which we don't know, x, and h on the bottom, which is 14.5. Okay, now to solve this equation, this is what it is now, it's an equation. We need x equals, okay, we're solving it. So at the moment we're dividing by 14.5. So we need to do the opposite, or the inverse of that, which is multiplying by 14.5. So in our calculator, we're doing 14.5 times cos 53. Alright, so make sure that your calculator is in something called degrees mode. So it should say a little DEG or somewhere to show that it's in degrees. Otherwise, it can mess you up a little bit. 8.7263, blah, blah, blah. Last point to make before we move on. 3 sig figs. So 3 significant figures. This is the first one, second one, third one. So we're rounding to there. So it's 8.73. Alright. Okay. A bit about interest rates. Quite useful for life, actually, and all sorts. Ella invests 7,000 for 2 years in an account paying compound interest. That's good to know. There are different types of interest. There's simple and compound. The first year the rate of interest is 3%. The second year the rate of interest is 1.5%. Work out the value of Ella's investment at the end of the 2 years. Actually isn't too bad, and if you weren't sure, you might as well put something to go in your calculator. Rate of interest is 3%, so your first step, 7,000 times 1.03, that's basically adding on 3%, is what that means, alright? You're adding on 3%. And then the second year of interest, it changes to 1.5, so all you need to times it by now is 1.015. It's just a multiplication calculation you're popping in at the end of the day. You pop them in, you get 7318.15. Alright. If you're not sure, and it's quite late on, you might as well give it a go by doing some times in. You might pick up something for it. It's worth 3 marks, but actually doesn't take very much. So you might as well give it a go. Okay, moving on. We've got a graph of x squared minus 6x plus 4. I'm assuming we're going to have some questions to do with this beautiful graph. I'm going to go through all 3 bits on here. So we've got the y-intercept to do. That is just where it hits the y-axis here. Alright, wherever it hits it. So the y-intercept 0, 4. Then we've got the turning point. In fact, let's do turning point in blue, spice things up. Turning point basically is at the bottom. Okay, and the coordinates of that, wherever it turns around basically, is kind of what it says. 3, negative 5. So that's negative 5 there, 3 there. And the roots are just where it hits. Now they are estimates, so they don't need to be perfect. Alright, so we're looking, I think, what's that, 0.8? I'd say 0.8. And then 5.2. Alright. Write down the intercept of y equals x squared minus 6x plus 4, and then the turning point, and then the roots. Alright. Then you just pop those answers in here. So y-intercept was, what was it, 4? You can just put 4. Turning point was 3, negative 5, and 0.8, and 5.2. Alright, there's your 2 roots. Alright, nearly there. This is really quick. Reciprocal just means 1 divided by whatever the number is. So 1 divided by 0.8. Pop that in. You get 5 over 4. Alright. And then error interval, correct to 2 significant figures. Okay, so we're looking at this column here. Alright, so the maximum and minimum that it can go up to. All we're looking at is how is it going to round to 4,700. How is it going to round to that? Alright, because if you went to 4,750, that takes you up. Okay, so anything less than that will round you to it, so that's your upper end. And then your lower end, 4,650, because that will round you up nicely to get to 700. Okay, which is why it's included, and that side's not included. Because if you include this number, it goes to 4,800. We don't want that, 4,800. Not what we're looking for. Alright, nearly there. Last question, beautiful sight. It looks like a percentage increase question. Increase by 9% between 2018 and 2019, and we've been told the value in 2019. Right, we're asked to find the original. All that means is something, let's just call it x, we don't know what it was, times by 1.09, 09, because it increased by 9%, it's going to give us 165,680. We can work this out then. We want to get rid of this times 1.09, so we're going to do the opposite, which is divide. Okay, pop that in your calculator, and you get a nice number of 152,000. I always think it's a green flag when you get such a beautiful number like that. That always tells me something looks good. And that's the end. Fair play, guys, we've done it. I'll be doing paper 3 at some point soon, so stay tuned, like and subscribe, and see you in the next one.